The product development train will soon be leaving the station. I should warn you that there will be stops along the way. Our first stop will take longer than usual, and most likely will include a mismatch of rules, false positives, and we will be wasting a whole lot of time there. Our next stop will include a data misinterpretation, including but not limited to backdrills, angles, and arcs. Don't worry, folks, this is all completely normal. We will absolutely not be keeping on schedule, and your design cycle will definitely be unpredictable at the very least. Sound like a train ride you've taken before? Yeah, me too. But it doesn't have to be that way. Our journey from design to production does not have to include delays, interruptions, or wayward deer on the tracks. Hi, I'm Amelia Dalton, host of Chalk Talk. My guests today are Hemant, Shah, Bryan, LaPointe from Cadence Design Systems, and we're navigating our way through these manufacturing handoff pitfalls with Design True DFM. We've got a ticket to ride, so let's get rolling. And before we leave that station, don't forget to click that link. There you can find out more information about Design True DFM from Cadence Design Systems. Hi, Hemant and Bryan. Thank you so much for joining me today.
Hi, Amelia. Thanks a lot for inviting me. This is great.
Thank you for having me.
Okay, so people are doing product integration every day. So what's the problem here?
You're right. The people are doing new product development and introduction every day. They have a set of tools they use today. And the problem we see, what we hear from our customers is that they design the board and then do a checking on whether it's manufacturable or not, and then find problems with it. Then they have to come back and fix the problems. And this iteration of going back and forth of finding problems is time consuming. And what's worse is when you find it too late in the design cycle, it costs you more time, more frustration to fix the problems. So it isn't early enough, essentially. And what that does, it causes delays in getting your product to manufacturing. So you delay your introduction of your process. And the other part that you find is sometimes your manufacturing partner will find the problem and then you will have to fix that. And that causes interruption of your work because the manufacturing partner isn't going to suddenly start working as soon as you hand them the board. And you're not just going to sit there and wait for the manufacturing partner to check it. So what happens is you start another project, deep into that project, and all of a sudden you get a feedback from the manufacturing partner. There's a problem you got to go fix. So it interrupts your work, delays your product introduction, and causes a lot of frustration and problems.
Bryan, what kinds of challenges were you seeing in your industry?
That's a really good question. I actually worked across multiple industries. The industries that I worked in ranged from consumer products, smaller products, watches, laptops, tablets, phones, all the way up to larger devices that consumers would never see, things that help the world go around, such as telecoms, medical, military products. They all have different challenges, but all of them need to be solved in a similar way. And the industry's issue, of course, as we talked about, is that the majority of these issues are caught at the end of the process. And as you're doing the design, the most gratifying moment you have is when you finally release that design to be manufactured. And having that come back with an issue that requires you to put more time in and change something, it's just the last thing that a designer really wants to see. If we could have a way to fix this live, it prevents so many issues across the board.
So people could run this manufacturing sign-off at the end of the day? What's wrong with that?
So the problem with that is that typically people tend to run a third-party tool that doesn't have the same level of or same type of interpretation of the data that we have. And so what happens is the data is extracted from our tools and input into a third-party tool, and there could be rules mismatch, which means you could get a false positive, which means you get an error and you go and look at it, but it wasn't an error. Or there could be interpretation mismatch in the sense that we have some capabilities in our tools that is not well understood by a third-party tool, and therefore the errors may not be caught. Or worse, it'll go all the way to contract manufacturer, and manufacturer will find the problems. So it could cause a bad board being built or spending more time trying to figure out where the problem is and why it didn't get caught. So even if you run it every day, it's a problem. But maybe we could ask Bryan, does this running every day process work?
It actually doesn't, and the reason is that on smaller projects it may be okay. What you generally do is you take that database and you have to convert it into something usable, and that data it's always a different format for the different vendors' solutions. And once you convert it, you still have to actually run the data. You have to test it, you have to analyze it, and then you have to look at the reports. And that whole process, even for a smaller board, can take an hour, 2 hours, and nobody wants to spend 25% of their day looking at a result that they could have had something, instantaneous. And now, of course, imagine a much larger project. That can actually translate to 6, 8 hours, an entire wasted day for every time you want to run this.
Okay, so what's the answer? What is Cadence doing to solve this problem?
So what we did was we recently introduced a new technology. This is the first in the industry. It's called the Design True DFM technology, and it's intended to solve this problem by, like Bryan said, knowing and finding the problem as soon as you make it. It's what we call in-design DFM checks using our innovative Design True DFM technologies, first in the industry to do this. What it does is ensures your design is ready for manufacturing with the shortest development cycle possible. Because you're not redoing your design again and again when you find the problem late in the design, you're able to fix the problem and move on. You are able to work on the design rather than working on the problems all the time. And these are real-time checks. That means as soon as you create a design element, we do the checks and tell the user there's a problem. And we provide over 2,000 checks that are independent of the electrical rules that we already provide for real-time checks. It's easy to use, easy to reuse, easy to apply the manufacturing rules.
Great. Can you show me an example?
Definitely. So here's a simple example. Here's a subset of a board that you look at it. You're looking at a few components being placed right next to a slot in the board. But this particular component here that's highlighted with a dotted line is placed too close to a slot. And if it's not detected early enough, then the designer goes in and places other components and routes other traces around it. Now, when the problem is found too late in the design cycle, not only does the designer have to move this component, they have to undo all the routing and all the placement around it. And it's too late in the cycle. Here's an example of how our tool catches it as soon as you place this component next to the slot. And as soon as you are told there's a problem, you can move it out of the way. Notice that while there may be other components around it, there's not traces around it. So you don't have to undo that work. So this is an example of how we can fix it immediately as soon as, and it takes a lot less time to fix it than if you wait later in the cycle.
Okay, so what about another example? We talked about fabrication. Let's look at assembly.
So here's another example. We've been doing back drill for many years. We've been the industry leader in supporting back drill capabilities. A lot of customers know about this, but these are drills that are larger than the plated through hole, essentially extracting copper out of it to prevent reflection problems with high-speed signals. Now, the rules that manufacturers give our designers is that there's a different clearance between the back drilled hole to a copper element nearby, a back drill hole to another plated through hole, or a back drill hole to a microvia. So there are different elements on the board and different kinds of rules that the manufacturer expects the designer to meet while designing the board. We've added about 50 back drill object rules in this project. Back drill to outline, back drill to cutouts, back drill to pins, vias, pad types, and so on. So we've added all of these rules to give the designer an immediate feedback as soon as they tag a particular plated through hole for back drilling. So they find out the problems as soon as they decide this via is going to be back drill. So let me give you a couple more examples, just so you understand. So here's an example, trays being too close to cutout. Earlier we talked about a component being placed too close to cutout, but you could have other objects close to the cutout. So we find that silk screen to silk screen, or silk screen to pad violations, it's too close, or a small opening within a shape, or a solder paste picking, maximum exposed etch in solder mask is violated. So these are some examples. We have about 2,000 plus checks that we added in here for the designer to be alerted as soon as any problem is created.
Is there anything else I can do to catch errors earlier? How early can we go?
That's a great question, Amelia. We can check these manufacturing errors even during the footprint creation. As you know, footprints are built in a library and then instantiated and designed multiple times. So if you can catch the error in the footprint creation process, that means you don't have to fix those problems with multiple instances. For example, annular ring is a great example. If there's not sufficient annular ring to it and a component has 50, 60, 70 pads on it or pins on it, then you fix it one time in the footprint and not have to do it with multiple instances of components on the board. So that's a great example of how we do it. So catching them earlier in the footprint creation cycle prevents the PCB designer from having to deal with these problems in the first place. So not only we make it easier for the designer to find problems, we help the librarian to create a footprint that's consistent with the DFM rules that you're targeting towards.
Okay, I get this, but how much of the flow can you cover? Are you really covering the entire process?
Great question. So we cover all areas of PCB fabrication and assembly. So we cover the etching, the lamination, drilling, plating, solder masking, silk screening, and assembly. We cover all of the process. And we make it very easy for the user to deal with it in Constraint Manager. Constraint Manager is where all your rules are, and we have now added in rules for manufacturing. And we make it very easy for user to specify the rules associated with either outline to everything else, a mask to everything else, annular rings, copper spacing. So there's a lot of copper elements on the print circuit board, and we provide the users the way to specify clearances between these different copper objects. We also provide analytics like whole aspect ratio. We support the full range of rules for rigid flex designs, which is very common these days. So we have covered all areas in the design process and the manufacturing process.
So Bryan, Hemant mentioned 2,000 checks. Isn't that going to be a problem?
That's a good question, because even if those checks are easy to input and there's 2,000 of them, no user really wants to have to change 2,000 easy checks multiple times. So a great thing that Cadence did is they introduced the ability to have what they're calling a rule deck. What this is the ability to work with a manufacturer, find out their specific requirements, and then input those as rules. So if somebody needed to switch between manufacturers, or there was a last minute change and now they need to go to a different manufacturer, the user can easily input a template file or a rule deck that will switch all the rules over to that appropriate template, essentially, and then they'll get the updated DRCs and they can make their changes. So from a designing standpoint, the inputting of the rules has been solved. You have to do it one time, you can reuse it across multiple designs, and you can even save them for multiple manufacturers.
So the other thing that this ability to handle multiple rule decks is that there are a lot of manufacturers out there that have multiple fabrication and assembly shops. And each fabrication and assembly shop is different. So the users through these rule decks can actually target their board to a specific facility. And if for some reason they need to change the facility, for some reason the manufacturer came back and said, no, I'm not going to build it here, I'm going to build it somewhere else, then it's an easy way for the user to import a new rule deck and check the design. And in this case, the earlier you change the rule deck, the better you are. But assuming you were changing it a little later also, we provide a very easy to use DRC Browser. It's new, it's brand new, taking this process into consideration, make it easy for them to quickly sort, browse, and review different checks. We give a pictorial feedback of what the rule violation is all about. We have a way for them to sort it by the category of rules and look at how many rules in a particular category. So we give them all the tools to navigate through the problems that they might run into, either in this scenario or in some scenario where they had, for some reason, because they were doing some local edits and they turned off the DRC DFM checks, they can come back and rerun the rules and look at the problems through the DRC browser and quickly and easily go back to the design and fix any problems that got introduced during that process.
Okay, so can you guys wrap up your main points for me?
Absolutely. So basically what this design through DFM technology is, it's shortening your design cycle. You're eliminating the need to rework your design again and again because you're finding the problems too late in the design cycle, or you have incompatibility of tools to do the design from one tool and checking with other tool. It overall shortens your development cycle. And what we've done is make it really easy to use this technology like you use our electrical rules in the Constraint Manager. DFM checks are just right there. No extra work for the user other than importing the rule decks. And that's it. There's no methodology change, and it shortens your design cycle.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Bryan and Hemant.
Well, thank you for having us. It was great talking to you.
Thank you very much.
And before we go, you didn't forget to click that link, did you? There you can find out more information about Design True DFM from Cadence Design Systems. For For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal or check out YouTube. Keyword EE Journal.